to try for the next half hour, hopefully, to show you like hands-on on how to do this kind of things. So when I say CI/CD pipeline for containerized databases and Kube-Native, there's two main things here. There's Kube-Native. So Kube-Native means that we're going to be using a CI/CD tool that is called Tecton, which is specific to Kubernetes, meaning that all the tasks are run in Kubernetes. So who is familiar with Tecton already a little bit here? A couple of you, so that's good. So that, if you don't know it, that's perfect for me. And then containerized databases means that as part of the pipeline, we're going to deploy an application that has a component that is a database that is containerized in Kubernetes, which means we're going to be using operators and operators for database. So who knows a bit about Kubernetes operators framework, a bit more, and operators for databases? Yeah, some of you. So yes, it should be fun. So a bit about me. My name is Nick Vermandé. I'm managing the DevRel team at Spectro Cloud, which is a team of one at the moment. So if you were at my talk yesterday, I exactly said the same thing. So if you want to change company or explore new territories, I'm recruiting. If you think you can be a good fit, come talk to me. You can find me here on Twitter. You can ping me on LinkedIn as well. I spent the last 6 years working on Kubernetes. Whether at large company like Cisco to other startups, I had the opportunity to work both in engineering, tech marketing, DevRel on the CNI, which is the container network interface, CSI as well, with a lot of different customers. So during this time, I met a lot of customers, also got a lot of experience, trying to get a good grasp of what they were trying to achieve, what were the challenges, etc. Other than that, I love metal, I love running, and that's about it. Okay, so let's get started. First, I would like to answer or ask the question, is it a good idea to run databases within Kubernetes? So who thinks it's a good idea? Yeah, just a few of you. Okay, so if you look first at some of the Gartner reports regarding the Cloud Database Management System Magic Quadrant, it basically says that by 2022, 75% of all the databases will be deployed or migrated to a cloud platform, with only 5% ever considered for repatriation to on-premises. And by 2023, the Cloud DBM revenue will account for 50% of the total database market revenue, right? So which means that people are going to consume, and this is the way, this is a trend, like they are consuming databases in the cloud. So it doesn't say if it's in Kubernetes, it's a SaaS or PaaS service. I would assume that most of the time, it's going to be a SaaS/PaaS service. But at the same time, if you look at the most, you don't see the same thing at all. Okay, I don't know, that was a bug. So at the same time, if you look at the most popular container images people are downloading, you can see that probably more than half of them are either databases, message queuing, or stateful components, which means that this is very popular. And what cloud provider don't tell you, right? So at first, it seems very easy to consume database in public cloud, but in reality, it's like an iceberg, like the hidden face, the hidden part of the iceberg is a lot bigger. They don't necessarily talk about costs. They don't talk about, the ability to move to another cloud, because let's face it, single cloud company, maybe they are, depending on the size, of course, but cloud provider is not necessarily a technical choice. Most of the time, you will find companies where there've been acquisition, mergers, or for whatever reason, one cloud equal one specific functions. Like maybe if you're a big Oracle customer, you're going to run your databases in Oracle Cloud, things like that. So you have rarely a single cloud. I mean, it can happen, but it's not always the case. So if you have a whole team that is managing your databases in AWS, RDS, or whatever, if you want to do it in another cloud, you have different API, you have to relearn everything again. Also, in terms of costs, things like RDS are super expensive because it's using EC2. EC2 means also EPS drives, if you want provision IOPS with dedicated performance, can be super, super expensive. Well, with Kubernetes, you have the ability to use some CSI, dedicated CSI, and basically you need to attract and consume different feature sets if you want to bring the databases at the same level as what you have, on RDS and things like that. So you typically, in a cloud-native environment, you need scalability, elasticity, self-healing, observability for your compute stack. But how about your persistent storage? If you want to reduce cost and be more agile and get everything into Kubernetes, you need a couple of things. It needs to be distributed. You need replication, encryption. It needs to be, self-provision from a developer perspective. You don't want to wait another, 5 days to get your databases as a developer. It needs to be DevOps friendly, which means that effectively you want to be able to get it into pipelines. So those features can be brought into Kubernetes by leveraging the proper CSI driver. And in the demo, we're going to be using the OnDat CSI, which is the name for what was previously StorageOS. It's basically a storage engine that provides you within Kubernetes all this nice feature like synchronous replication, ability to export your backup, encryption, inside your cluster, all of that. So this needs to be combined. So on the storage side, we have all those features. This needs to be combined with some way to natively create databases inside your containers, right? So by default, the database is a stateful application. So I encourage you to maybe watch my talk from yesterday about stateful application. So that means that we need to be using stateful sets in general and do two things, right? When you deploy the database, you need first to scale, of course, the number of pods into your stateful sets. That's the infrastructure layer. But at the same time, you also need to install the database. And this is typically where you need an operator. You don't want to be maintaining your database, status and health manually. You want an operator that encapsulates the knowledge on how to do this. You want an operator to do that for you. And here, this is an example of the MongoDB Enterprise operator. We're going to be using in the demo the Community Edition. So the Enterprise, of course, you have to pay for it. You have extra features like here you can see you have the ability to do backup of your database. And you have full lifecycle management. With the community operator, it's basically deploying the database, and as you scale the stateful set or you scale up or down, then the state of your cluster is changed accordingly. So if you increase the number of pods, you will have a larger MongoDB cluster. If you decrease the size, it will adapt and then reduce the size of the cluster, but always with a finite state that will be healthy with the appropriate number of members. And this is what is important. If you don't have the operator, well, you have to do all of that manually. And why an operator? So here is just to show you an operator can do many, many different things. Today, in the context, we're not be using it for a database, but nothing prevents you to do anything with an operator, and that include managing resources outside of Kubernetes. So the idea of the operator, for people who don't know what that is, it's composed of a custom controller and custom resources. So effectively, it's extending the Kubernetes API by giving you the ability to create custom resources. It's not a pod anymore. It's not it's not a service. In our case, it will be a type, an object that is called MongoDB. And it can be anything. It can be a VM. It can be an instance on AWS. You can encapsulate or represent whatever object you define yourself. So if you want to extend that concept, you can even start using Kubernetes as an automation engine by itself, like replacing Terraform or any of the infrastructure as code or as data, should I say. And by reacting to what's happening in the cluster, so the creation, deletion, or update, so the CRUD operation on your custom resources, the custom controller will take some action, some logic, and this is up to you to create that logic. So in this example, you can create like on AWS, Azure, Google Cloud, whatever object you want to manage there, and implement that into Kubernetes and manage the automation, the lifecycle of outside object that can reside in the cloud or on-prem using that sort of automation. So the point here is like operator is super powerful, and this is how you can extend Kubernetes, the Kubernetes API, right? And considering Kubernetes as an automation engine and just a next generation infrastructure platform. So our app for today, so I've written a couple of blogs. Actually, it's a 3-part series where I walk through all how to install, the database operator and some other tools that you can find on this link. But basically, this is an application I've developed for that particular demo. It's composed of 2 microservices, or 2 tiers, should I say. We have the front end, which is a Flask application, just used for displaying, a nice way of, getting some other information. And this is a Marvel character cards. So you will have a display with different cards from Marvel characters with a picture and displaying where the character was in different comics, like the different comics it appears in. So the role of the front end is just to display that, and we will have a cluster, a MongoDB cluster with a headless service on top. Headless service, this is how you manage a service from a stateful set. So everything is managed through manifest and this part of the pipeline. And the Mongo cluster itself will be a 3-node cluster. And on top of this, I also have a job, right? A job there. The role of the job will be to get to perform some API requests from the Marvel public API to get all this information in a JSON format and store it in a semi-structured way into the MongoDB, right? So MongoDB will be populated by the job, and then the Flask front end will display what is inside the database. You will see that the job may fail because the job will try many times to do this task and push it into the database, but it needs to wait for the database to be ready. So the job will try again and again until the database is ready. Once the database is ready, the job should succeed. And then we will have just a stateful set, which is composed of I think that's the database, basically. So three pods with a storage class, where this is where I'm going to specify the extra storage feature I need, such as replication and encryption. And then the volume claim template, this is how I manage this for the entirety of the stateful set. And then in terms of how the database is provisioned, is by, again, using a manifest, because the operator is already sitting in the database, right? So it's basically everything inside Kubernetes. The pipeline, the database definition, the database object is there. Nothing outside of Kubernetes. And yeah, this should be like what we have at the end. So this is what the pipeline look like, and normally like 15 minutes should be enough. So if you like the whole pipeline, usually what I do like from a developer laptop with local cluster to production. But for today, we're just going to do the production part, which is this one. So we start by, of course, having the code developed by the developer. We commit the code into a repository. And the pipeline, this is basically where it starts. It's the Tecton Pipeline, I'm going to trigger it manually. You can trigger it by using any sort of event like a git push or a merge, whatever. So the first step is going to be to build the container image using Tecton and push. So here we are here in Tecton. We are pushing that image to Docker Hub. To build the container, we are using Canico. So this is how you build images. So who is familiar with Canico? A little bit? Yeah, some people here. This is the preferred way my preferred way to do this in Kubernetes. So you don't have to use Docker or mount the Docker socket, which is a very bad practice. So Canico, it's a very secure tool developed by Google, a very secure way to build container inside Kubernetes if you want. So then Kaneko is going to push the image to Docker Hub. And then from there, we will have a second task that will use Customize. So I guess who's familiar with Customize? Yeah, some of you. It's a way to customize your manifest, your base manifest, with more specific configuration and generate the end result manifest for your specific configuration or context. So we're going to Customize is going to be launched as part of another task. Another task means another container as well with Tecton. So a second container will be launched and create the new manifest. The manifest will be again pushed to a Git repository, and then we will have Flux monitoring it. I mean, Flux can by default have customized integration, but in the context of that particular demo, the customized part is done by Tecton, and Flux will just watch for that particular directory within the repository where I have the manifest that will pop up. And because Flux is a GitOps tool, its job is to monitor what's happening in the GitHub repo and react and reconcile in the cluster. So as soon as it's going to see my application manifests, which will be composed of all the what I've mentioned before, the job, the deployment, the service, the database, all of that, it will be deployed in a single very large manifest. Flux will react to this by deploying this into the cluster. And then we should have a working application. That makes sense? That's a lot, but hopefully in the next 15 minutes we'll be able to do that. So let's go. I've tried it twice. So if it doesn't work, it's not my fault, I promise. Right? I didn't sacrifice any goat or baby, so we'll see. OK, so let's start maybe with what we have here. All right, so let's start with the Tecton pipeline. So Tecton takes some time to get familiar with. At the beginning, it made me think about Terraform in the way it's structured, because you have input, variable, output, resources, all of that. But the idea is to perform a suite of consecutive tasks. And it's divided into three different things. Like a pipeline is composed of tasks, and tasks consume, and pipeline consume resources. So our big pipeline is called Pipeline Marvel App. And essentially, we have a lot of definition here, but we have reference to various tasks. So here, if I start with the task, first is build app. Then you have the task ref, input, output. Then we have the customize manifest. Second part, we generate the manifest by replacing the image we just have pushed into the Git repository and replacing that image into the manifests. And then the last task is, where is it? Here is push manifest to the repository that is that is watched by Flux. So those three different tasks are there. There is this build Docker image. This one, I don't need it. It was just for a test. But you can see that one is missing. The one that is missing is the one that is pushing the manifest to the Git repo. And this is what I like about Tecton, is that there is a Tecton Hub. Tecton Hub, you can find any sort of task you want to do. So here I've used Git CLI. So you can install it. Install, it will tell you, OK, you copy this manifest, kubectl install, and this will be installed into your cluster. So in the way it is managed here, hopefully, can you see it properly? Yeah. If you watch for the CRDs and then look for Tecton, yeah. All of that, all those concepts I've mentioned, they are basically CRDs in Kubernetes. Right? So in the same way, Mongodb is a custom resource representing a database object. Here, Tecton implements all those custom resources that represent Tecton components, so all the pipelines, the task, etc. So once you install the Git CLI, you will have the task that is available to consume directly as a custom resource into Kubernetes. Right? So, so this is why you don't find it here. It's because it's installed directly by using the kubectl apply you get from Tecton Hub. So once you have all those files defined, you have to apply them, or you have to import them or ingest them into your Kubernetes cluster. So all the dash run here is not the one, right? So all those ones have to be installed into the cluster. Right. So you do it once, then it stays in the cluster, and the only thing you have to do now is, in Kubernetes, as always, it's a matter of creating objects. So if I create the pipeline run now, it's going to trigger the pipeline. But just before that, just the customized configuration quickly. So for people who are not familiar with Customize, as I was saying, is a tool that helps you repeat and build a repeatable framework to deploy your application by creating an overlay over a base set of manifests. So here we have the base manifest that represent the basic application configuration with the job. I'm saying here like the resources that are part of that application I want to customize. The deployment, the headless service that you need for a stateful set, a representation of the database, which is my custom resource, and the storage class that will add my extra storage features. So if you look at the overlay, this is where it gets a bit more interesting. Right? In the customization here, this is where I can do fancy stuff. I can merge the base with my overlay, so basically ingesting the custom configuration into a resulting set of manifests. I can do strategic merge. I can do JSON patch if you want here, which I needed. I'm then just saying, OK, where is the base? And I can also generate dynamically things like config map, secrets, and even more powerful. Here, for example, you can see that in my MongoDB, I've got a password secret, right? But this is not like a native Kubernetes secret, but I still want to be able to generate dynamically a password and a secret using the customized function, but something that is not a secret, that is a password secret. And for this, you can also do this with Customize, where you can create what we call configurations. A configuration basically gives you a kind and a path, right? Where the secret, it's a kind secret, right? So this is where I'm going to, basically create the dynamic configuration of the secret. It's not a normal secret. It's a MongoDB specific component, but I can incorporate it with the dynamic generation feature of Customize, which is quite handy. And then I've got the storage configuration here. I want encryption, again, and replication. So this is as easy as that. Don't need to go in the cloud or create like a fancy API request, automate anything. Everything becomes declarative once it reaches Kubernetes. And that's the idea, right? So now let's run the pipeline. So hopefully it's going to work. And then we can monitor it live here, and at the same time, I'm going to monitor Flux as well. Flux, where is there? So let's do Flux, oops, here. And in my cluster now, I should see here, you will see like, this is the new container. This is the pipeline that is starting. And if we go back here, at some point, once everything is done, we should see a new line here saying that Flux has picked up the new configuration. And if we go there, it's still building the container image. So that's the first task. After that one, it should hopefully use Customize to create the new manifest. And if you go into the task Customize, it's just basically a script, right? Customize build and my current directory where all the configuration is, and generate a new manifest. So it's just a script, literally. So typically, like this is a container with some commands. This is what every step of your pipeline will be, right? So here it's pushing to Git, and everything is done. So so the Tecton, the customize was super fast, and then we have here the Git push of the manifest. Now on GitHub, I should see here in my target, I should see something popping up 21 seconds ago. And that's the manifest that has been generated. Maybe you don't see it quite well here. That's the manifest that has been generated by Customize. So basically a merge from the base plus the custom configuration is there. And this is what Flux will pick up and hopefully deploy into the cluster. So let's take a look at Flux. So yeah, we see here a new line. It's like now reconciling the cluster, so we should see some component deploying already. So the front end has been deployed, right? 5 pods. The stateful set with the MongoDB is being created, and we have the job that is trying to populate. This is the job, add data to MongoDB, but it's going to be failing until the stateful set is provisioned. And stateful set takes a bit more time because it proceeds with the next container, not before the first one is effectively running. So in the meantime, yeah, I wanted to show you all the CRDs I have in this cluster, and also to show you like the Mongo here. So here, this is really showing that I've got the MongoDB resource type that is there in the cluster. So it means that when the operator is effectively there, and once the custom resources is ingested into the cluster, it's recognized by the cluster, and the custom controller will deploy the database accordingly. And there's even better. So I don't know if you're familiar with this command, but it took me some time to know it when I started Kubernetes, when I started actually to work on my certification. It's Kubernetes explain. Who's familiar with this? A couple of you. It's super powerful. So here, like, it also works with custom resources, right? Because it's part of Kubernetes now. So it gives you all the parameters that are available with your custom resource. So in MongoDB here, this by default, like just looking at this this output, you see what you can configure as part of your operator. Because usually operator documentation is not the best, so you will have to figure out by yourself. And if I go back here in the MongoDB, the only thing I'm using here needed to change literally is the stateful set part of the MongoDB manifest, which is essentially saying, please use that storage class where I have all my feature. So my PVC, so my PV, my persistent volume, my volume can be replicated and encrypted for that particular database. I need to specify the right storage class where I have this configuration that is active, right? So for both the data volume as well as for the log volume. And now if I look at the PVCs, of course, you should see, here you go, PVC. So you can see a lot of PVC. So the storage OS, the OnDat solution is also using etcd internally. So this is for that, because the storage solution itself is running as container, right? It's container attached storage. We have the data logs PVC, and quite interestingly, PVC are also used by Tecton. So which means that you also sometimes they're like unexpected things that are used, like PVC during a pipeline. Yeah, why not? Which means that you also have to take care of those PVC and maybe guarantee like that those PVC are remotely accessible by using the proper, production grade CSI, all right? Which can be very important. And then we have 3 stateful sets with every time data volume and logs volume. So now, what does it say? So we have 2 fail, like error, 1 that has succeeded, right? So now we should have the database populated and the application should work, hopefully. So let's pour forward this one. That should be working. So I'm just redirecting the application locally on my laptop. And if I go to localhost 8080, so let's pray. What do you think? It works? I think it works. It works. No surprise. Yeah, we did it. So fancy one. My daughter really liked this application. Actually, she wanted me to do it, so I did it. You can reload. I've got probably 800 different characters. I didn't want to ingest the whole database. So yeah, it's just working. You can refresh pretty much everything. Yeah, that's cool. All right, so I think that is it for today. Let me check on the slide. I think this is pretty much it, right? Let's go back. Yeah, this is what we did. So hopefully it's been fun, useful. You've learned one thing or two or more. So now I guess I'm ready for any questions.
Thanks, Nick.
No questions?
Great talk. Yeah, we do have a few questions.
Okay.
We can start off. There are some proper dev questions as well, but I'll explain those in a bit. So the first one is, will Tecton be able to integrate with vulnerability scanning tools before deployment?
Yeah, I guess as long as it runs within the cluster, it's fine. Or you can also have them, your configuration is YAML, so you can of course commit them on Git, and you can run some tool there for whatever vulnerability checking, like image or whatever. Why not use customize as a pre-commit instead of...
So I'll just read it out for the people online as well. Why not use customize as a pre-commit instead of generating an additional commit in the CI?
Because I could. No, I wanted to show custom, it's not customized just as a step as part of Tecton, right? You can use, there's many different ways to use customize. I just chose this one for the purpose of the demo.
So won't the most downloaded images be a bit skewed? Be a bit of a skewed view. It is likely more local development compared to production usage. It went down.
On Tecton Hub, those images are sort of templates. So you still need to put your inputs and sort of configure them. So it's more generic. So I don't think they are too opinionated, right? So most of the time they are kind of neutral. It's up to you to create your inputs and resources. So but it may be the case indeed. Yeah.
I'll go for the tech ones first. Does the MongoDB operator support PV resizing?
Yes, actually, in the file you can see I specify the size of the PV. Or you mean maybe after? Yeah. So after deployment, PV resizing is a support of the CSI. So if the CSI supports it, it should be fine, right? Because the file system will then support it after.
Cool. And then operators are cool as long as they work, which is
When things gets ugly, so this is why I've shown you a kubectl explain. Right, that's the first thing to know about the different resources, and then if you need to know what the operator is doing, then you have to get into the controller code and see what's happening if you have still issues. So far, I never needed to go into the controller, custom controller code. The only thing I struggled was all the different configuration items, what they mean. Is it in gigabits or is it in meg? Sometimes it's not so obvious. But yeah, you have to spend some time. That's the problem. And the benefits of operators is extension of the API, right? Which means extension, you can do pretty much whatever you want. There's no standard. But yeah.
Cool. OK, so now to the hardcore questions. Which tool are you using for monitoring containers at the demo?
It's K9S.
It's a really cool tool.
Yeah, it's probably the most useful, interactive runtime Kubernetes, UI or UI. Yeah, UI.
I'll go for the last one. What is your VS Code culling?
It's I'm gonna ask what's the name of this? Space Mac, because I love Space Mac. So it's the same theme. Which is a mix of VI and Emacs, so I can stay neutral.
Yeah.
OK.
I'll take... Can you perform zero downtime database upgrades using the Mongo operator?
Yeah, because two things, right? You have the operator and you have the stateful sets. So the stateful sets, again, watch my session from yesterday, which is how it upgrades as opposed to deployment, right? So it guarantees that one container is upgraded after the other. You can do canary upgrade as well, but it won't be a full parallel sort of updates Therefore, you will still have, like databases. Your database will still be healthy. At some point, of course, it will, like a container will be down, so you will be in a degraded mode, but as long as you have, the quorum, it's fine, right?
And final question. This is the crux of it. Do you use containerized databases in product?
So I'm not. I work in DevRel, right? So I'm not like a traditional customer, but my previous company was on that. This is why I've used it. And we had a lot of customers using databases in production, because I think now it's depending on the database. So my advice would be pick a cloud-native database. Like, it can be MySQL, of course, but MongoDB, cloud-native, Cockroach, all those sort of database. Then you can use the proper operator and service, like enterprise level, with companies like Peconas and others. I think now we reached the state where you can really do it in Kubernetes and also lower your costs, provided that, because to me, the DBA job doesn't really exist anymore. It should be a necessary job, simply as simple as that. So whether then you do it in Kubernetes or in the cloud is up to you, but in my opinion, you will save costs if you do it in Kubernetes and increase your availability. Like something, people don't know, or maybe they know, but they realize it after. If you run your database in RDS in AWS, then you're limited to a single region, right? If you need to recover your database, it's EBS snapshots and recover it in another region. If you use the proper CSI, maybe with a multi-cluster solution, database, with export backup possibilities, your time to recover will be a lot less than using AWS. So in my opinion, you're lowering the cost using it in Kubernetes while also increasing your SLAs. But
Cool.
That's my opinion.
Awesome, Nick. Thanks.
All right. Thank you.